Hello, everybody. We are back with another visual pattern challenge. Here is step 1 in our pattern. Here's step 2, and here's step 3. And your challenge, if you choose to accept it, is to predict, well, in this case, how many white boxes, we're going to ignore the shaded part, are in step number 4. And then a higher level of difficulty, if you can, how many in step 43? And can you write an equation to predict the number of white boxes in any step at all? So if you'd like to accept that challenge, pause the video, work it out, and see how you do. All right, well, I think in just looking at this pattern, it's clear to me that x squared is going on here in some sense, right? We have, here's a 3 by 3 square, here's a 4 by 4 square, here's a 5 by 5 square on the outside, or for the whole thing if you count all the squares. And then the inside, it's 1 squared, 2 squared, 3 squared, right? This is a 1 by 1 square, 2 by 2 square, 3 by 3 squared. So it looks like the shaded part is just x squared. And I think before doing anything else, I could already write a formula for this, right? The whole big box is the step number plus 2, right? So here's step number 1. If you add 2 to that, you get 3, and you get this 3 by 3 square. So the outside, or the total, is the step number plus 2, and then square it. The shaded area is just the step number squared. So if we subtract that, so if we take away the shaded area each time, this should give us the number of boxes. At least I think so. We'll test it and see if that works. So before we go on to testing, let's actually just try to draw out step 4. So we're doing this visually. This is a 5 by 5 square, so I think the next one is going to be 6 by 6. That's my prediction. So we'll do that. So 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So now I've got 6 in each, and then this is the shaded area in here. So if we look at the unshaded boxes, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I've got 20 in step 4. And that looks right to me. The inside shaded area is a 4 by 4 box. That's following the pattern 1 by 1, 2 by 2, 3 by 3, 4 by 4. So I think this is right. So I'll jot this down for how many in the next step. I think that's 20. Does it check out with this crazy little formula we came up with at first? So the step number would be 4. So I'd put in 4 plus 2 and then square it. And then I would subtract x squared. That's the step number squared. So 4 squared. Well, 4 plus 2 is 6, squared is 36, and 4 squared is 16. Look at that, I'm getting 20. So that seems to work. You can try this formula with the first step and the second step and so on to test it further, but I think that one works. I'm not going to write it down as our equation yet because I'm not sure this is the simplest equation there can be. And to determine that, I want to actually make a chart here for the step numbers and the number of boxes, white boxes. So in step 1, that's 6, 7, 8. So 8 boxes in step 1. In step 2, 4 and 4 is 8, 9, 10, 11, 12. In step 3, 5 and 5 plus 3 and 3 is 16. And in step number 4, we determined we have 20. And what we like to do is take the differences here. So 12 minus 8 is 4, 16 minus 2 is 4, 20 minus 16 is 4. Well, that's interesting. When you get the same difference in every step on this first set of differences, this becomes a linear equation. You can use a linear equation to express it, which means we don't need an x squared. It's simpler than that. And in fact, we're just adding 4 every time. So we could say y equals, so the usual form is y equals mx plus b, the slope-intercept form. The slope here is our change in each step. So this is 4x, and then plus whatever you need to make it work out. In the first step, we have 8 boxes. So 4 times 1 would be 4. I'd need to add 4 to make that work out to get to 8. Let's see if that works with our prediction for step 4. So y equals 4 times step 4 plus 4. And 4 times 4 is 16 plus 4. Yeah, that equals 20. So this is a lot simpler than this. What's going on here? Why do we have two different equations that both seem to work? Well, I'm going to do a little math with this one, if you'll just bear with me for a minute. I'm going to FOIL out this x plus 2 squared. You can try that in your own. X plus 2 times x plus 2. It's going to give you x squared plus 4x plus 4. And then we have this minus x squared. And if we combine the like terms, this x squared and the minus x squared, they cancel out. And look what you're left with. 4x plus 4. That's exactly what we had here. So the simplest way to write this equation is y equals 4x plus 4. So this is an interesting case where even though it appeared to be a quadratic kind of function on the outside, or quadratic kind of property, it really is simpler than that. It's really a linear pattern in disguise. All right. The last thing to do here is to figure out how many in step 43. And with this simple equation, we can do that pretty easily. So y equals step 43 plus, 4 times step 43 plus 4. 4 times 43, well, 4 times 40 is 160, and 4 times 3 is 12. So that's 172 plus 4. That's going to equal 176. So in the 43rd step, there should be 176 white boxes around the outside of that big square. Well, how did you do? Did you get step number 4? Did you get step number 43? How did you do the equation? Did you fool around with x squared, or did you realize it was linear and go right to the simpler version? Let me know. Thanks, everybody.